Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find the length x of the polygon? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. Meet the five-sided polygon ABC segment DE. Its left side, segment AB, is drawn in red and labeled x, and finding that length is the whole puzzle. Everything we need is locked inside the right angles at the corners. Walk the right side of the shape. Side ED is 3, side DC is 4, and side CB is 5. This 3, 4, 5 chain of edges from E through D and C to B carries all the given numbers. The corner at E carries matching tick marks. The side EA equals the side ED, so segment EA is also 3. Store that horizontal leg segment EA away because we will need it at the very end. Three corners are perfectly square. The angle at A, where segment EA meets segment AB, the angle at C, and the angle at D are each 90 degrees. These three right angles are the engine of the whole solution. Our first insight is this. Two perpendicular pairs force parallel rails. Because segment DE and segment BC are parallel rails, the perpendicular connector segment CD measures the constant distance between them. That gap is 4, and we will reuse it as a height in just a moment. Here is the plan. Connect E to B with a single diagonal, splitting the puzzle into two right triangles that share this line. Watch the navy segment EB appear now. Measuring it is our first goal, and it will unlock X afterward. From E, drop a straight perpendicular onto the line through B and C and call its foot P. The base segment BC is a little short, so extend it past C until the perpendicular lands. This builds right triangle EPB, in which the diagonal EB becomes the hypotenuse. Because segment DE runs parallel to segment BC, every point of segment DE sits the same distance to the right of that base, and that distance is exactly the connector segment CD, which is 4. So the horizontal leg segment EP equals 4. Look at where D lands. Since segment CD is perpendicular to the base segment BC, moving D straight to the left onto that base lands exactly on C. So the point directly to the left of D is C itself. A second insight now finishes the structure. Projection transfers segment ED to segment PC. The base of our right triangle runs from P through C to B. Add the 3 of segment PC to the 5 of segment CB, and the full base segment PB measures 8. Triangle EPB has its right angle at P, so the Pythagorean theorem applies. The hypotenuse segment EB squared equals the leg segment EP squared plus the leg segment PB squared. Now we fill in the two legs. Square the height first. Segment EP is 4, and 4 squared is 16. Now square the base. Segment PB is 8, and 8 squared is 64. Add the two squares together. 16 plus 64 is 80. So the diagonal EB squared is 80. Hold tightly onto that number. It is about to travel into the second triangle. Return to corner A, where side EA meets the red side AB. That corner is one of our right angles. So triangle EAB is right angled at A. In this second right triangle, the diagonal EB lies opposite the right angle, so segment EB is the hypotenuse. The two legs are the known segment EA and the unknown red side AB, which is our X. Apply the Pythagorean theorem again. The hypotenuse segment EB squared equals segment EA squared plus segment AB squared. This is the equation that finally contains x. Substitute what we know. Segment EB squared is 80, and segment EA is 3, whose square is 9. So 80 equals 9 plus x squared. Subtract 9 from both sides to isolate the unknown. 80 minus 9 leaves 71, so x squared equals 71. Take the positive square root, since x is a length. X is the square root of 71, and because 71 is prime, this root cannot be simplified any further. So the answer is square root of 71. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.